Welcome to CrystalMaker 10. In this tutorial we're going to take a look at our new live powder diffraction mode, which is a great way of understanding how structural behaviour such as this phase transition in barium titanate perovskite affects the powder diffraction pattern. I'm going to start with a very simple cubic structure in CrystalMaker. So I have an empty window in CrystalDiffract, which I'm going to use. In CrystalMaker, I can send the crystal structure to CrystalDiffract from the Calculate menu using the new Powder Diffraction submenu, and we're going to simulate a new pattern. And there it is. Now I'm going to call this Original, and I'm going to use CrystalDiffract's inspector to set the color for this and to also set the labels. So let's have we'll have a black pattern for the original pattern, and we're going to make sure that all of the peaks are labeled for the reference pattern. Now I'm going to want to make some modifications to our structure. So I'm going to need a second diffraction pattern for the modifications. So I can go to the Calculate menu, Powder Diffraction, and we'll add another pattern to the window. And this is our green pattern, and let's call this Modified. And then we can close our patterns list. We don't need that anymore. We'll just use the inspector to make sure that the modified pattern also has all of its peaks labelled. We're going to stack these patterns on top of each other so that we can see the modified pattern, and I'm going to just change the colour of the modified pattern to red. I'll give it red labels as well. Now I can hide the inspector, and we'll just resize the CrystalDiffract window so it matches the CrystalMaker window. Okay, so we have a modified pattern, and here's our crystal structure. Of course it looks just the same as before. Let's make some modifications. So I'll go down to my tool strip, and I've chosen the Add Atom tool, and I'm going to add a silicon atom, and I'm going to stick that silicon atom somewhere in the unit cell. And I want to see how that's going to change the diffraction pattern. Now I can do that one of two ways. The Calculate menu has a Replace Pattern command, so I can make a change and then replace the frontmost diffraction pattern in CrystalDiffract. But I want to do things in real time, so I'm going to enable live diffraction. So when I do this, any changes I make to the crystal will immediately be reflected in CrystalDiffract. So let's do that. Well, we haven't done anything yet, so the pattern looks just the same. Well, let's click and add a new atom, and let's see how that affects the diffraction pattern. So I can select this, and you can see immediately as I start moving this atom around, then the intensities of the red peaks start changing. Now we currently have a cubic primitive lattice, a P lattice. Let's move this atom towards the middle to turn it into a centered lattice, and let's see how the intensities of those peaks change. Now I want to put this atom exactly in the center of the unit cell, and the best way to do that is to go to the Selection Inspector in CrystalMaker and click on Edit Coordinates, and I'm editing the fractional coordinates here. I want to make this atom at a half, a half, a half. There we are. Now did you see the change to the diffraction pattern? Over here in CrystalDiffract, notice that the red pattern has suddenly lost the 120 peak and the 111 peak and the 212 peak. The only peaks that we have less are the peaks where H plus K plus L is even. So 011, 002, 112, 202, 103. Let's make some more changes. Here's our selected atom. Let's move it very slightly off center, and oh, there we are. The peaks of the form H plus K plus L is odd start appearing if we move back towards the center, they disappear. We move it away, they start appearing, back to the center, they disappear. Move it towards the origin and there they are again. So this is quite a nice way of looking at the effect of atomic displacements on the powder diffraction pattern. I have a second example to look at now, and here we're going to look at the tetragonal to cubic phase transition in barium titanate perovskite. So on the left hand side of the screen we have the crystal structure of barium titanate, and this is the cubic phase, and you can see the corresponding diffraction pattern is shown on the right hand side of the screen. Now I can use CrystalMaker's structures list, and you'll see that we actually have a series of structures in here. We have the tetragonal structure, the cubic structure, and then I've used our new interpolate structures command to generate a sequence of intermediate structures. Now I want to see how the difference in the diffraction pattern is, and I can go to the calculate menu and I can replace the active pattern with the current structures. And you can see this is the tetragonal pattern, gives us some splitting, and if we go to the cubic pattern we can do the same thing again. We can replace the active pattern and we get a pattern with fewer diffraction peaks. Now we'd like to be able to do this live, so we'll do what we did with our simpler example and we'll enable live diffraction. And now what we can do is we can actually go backwards and forwards amongst the different structures in our structures list, and we can watch the diffraction pattern change. And we can actually run this as an animation, and I've actually set the structure to rotate whilst it animates, and so here we can see a changing distortion. So the central titanium atoms become off-centered and their tetrahedra stretch at low temperatures, and at high temperatures they move towards the centers of their octahedra and the structure becomes cubic and the diffraction pattern becomes correspondingly simpler. So this is a nice example of live powder diffraction being used to understand a structural phase transition.